expression which is an inequality, and we are required to calculate the number of integer values of x with such that x is less than 100 which satisfy the given equation. If you are looking at the inequality, the first thing to notice is that this is greater than or equal to 0. So it is a key thing to notice that it is not strictly greater than 0, it is greater than or equal to 0. The second thing to notice is that there are many expressions or many parts of the expression which we can say for sure are greater than or equal to 0. For example, x plus y whole square in the numerator will always be greater than or equal to 0. So here we can ignore this, because whatever it is the left hand side, if you are looking at the other parts, you are multiplying it with a number which is always greater than or equal to 0. So the sign will not change. The next thing you should notice is that there is x square plus 3 in the denominator which is always greater than 0. So that also can be easily ignored. Similarly, if you are looking at x square plus 2 in the numerator, this also is always positive. So again, that can be ignored when you are trying to figure out what are the values of x for which this inequality is satisfied. So the only things that we'll have to notice are x square plus 6x minus 7 divided by x minus 2. Now remember what we said, that we know that the inequality is greater than or equal to and not strictly greater than. Because in this particular case, as this is greater than or equal to, we are even considering the case where x plus 5 whole square will be equal to 0, or when x is equal to minus 5. In the other case, where if there is a strict greater than sign, then even then we can ignore x plus 5 whole square, but we have to keep in mind that x cannot equal minus 5. But that can be ignored right now, that condition, because even when x is equal to minus 5, x plus 5 will equal 0, and then still the inequality is satisfied. Anyways, coming back to the current situation, we have x square plus 6x minus 7 divided by x minus 2. This has to be greater than or equal to 0. The denominator cannot be equal to 0, so x cannot equal minus 2. X cannot equal 2 because x minus 2 should not be equal to 0. Now if you are multiplying the numerator and denominator with x minus 2 whole square, that is a positive number, so the expression will be transformed to equal x square plus 6x minus 7 into x minus 2 is greater than or equal to 0. X square plus 6x minus 7 can be factorized to equal x plus 7 into x minus 1 into x minus 2 is greater than or equal to 0. What are the roots of the expression on the left hand side? The roots are minus 7, 1 and 2. If x is greater than 2, then all the three terms are positive and the product of three terms will be positive. If x lies between 1 and 2, the value of x plus 7 will be positive, the value of x minus 1 will be positive, but the value of x minus 2 will be negative. So the product of two positive terms and one negative term will be negative. Similarly, if x lies between minus 7 and 1, it will be two negative terms, that is x minus 1 and x minus 2 will be negative, but x plus 7 will be positive. And so the product will be positive. If x is less than minus 7, all the three terms will be negative, so the product also will be negative. Now what are the integers for which this product is greater than or equal to 0? Again, it is important to notice that we have greater than or equal to 0. When x is equal to minus 7, the product is equal to 0, so that will be counted. When x is minus 6, it will be positive, and it will be positive for all the numbers which lie between minus 7 and 1. So minus 6, minus 7, dot dot dot, 0 and even 1. Again remember that the key difference is that here we are looking at greater than or equal to. If it was strictly greater than, we shouldn't have counted minus 7 or 1, but now we should count both of them. The next interval is between 2 to infinity, but here we have a restriction that x has to be less than 100. So the given numbers will be 2, 3, dot 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 till 99. But again remember that x cannot equal 2. So 2 is not counted. So what are the total number of integers which satisfy this given inequality? That will be 9 numbers over here and 97 numbers in the second interval. So the total will be 9 plus 97, which is equal to 106.